Hello everyone, myself Assistant Professor Vatsal D. Patel from Civil Engineering Department working at Mahatma Gandhi Institute of Technical Education and Research Center NAVSARI. Today we are going to discuss about THEODOLITE traversing. So our today's topic is introduction and definition. So first of all, what is theodolite? So theodolite is used to measure the horizontal and vertical angles. Theodolite is more precise than chain survey, magnetic compass or plane table. So a theodolite is an important instrument used mainly for accurate measurement of horizontal and vertical angles in surveying. It is an extremely useful instrument to a surveyor because of its various uses. The theodolite is sometimes known as a universal instrument. So, theodolite is used to measure horizontal and vertical angles when the objects are at a considerable distance or situated at a considerable elevation or depression. It becomes necessary to measure horizontal and vertical angles more precisely. So, these measurements are taken by an instrument known as a theodolite. So let us see application of theodolite or say uses of theodolite. So for measuring horizontal and vertical angles, locating points on a line, prolonging survey lines, finding difference of level, setting out grades, ranging curves and tachometric survey. So let us see classification of theodolites. So based on movement of the telescope on horizontal axis in a vertical plane, it is divided into two parts, transit theodolite and non-transit theodolite. And based on arrangement to measure the angles, it is divided into three parts, vernier theodolite, micrometer theodolite and electronic digital theodolite. So let us see first of all based on movement of telescope on the horizontal axis in a vertical plane. So first we will talk about transit theodolite. So in case of transit theodolite, the line of sight can be reversed by revolving the telescope through 180 degree in a vertical plane. Internal focusing telescope is used in this theodolite. These theodolites are mainly used for surveying. Next is non-transit theodolite. So in case of a transit theodolite, the telescope cannot be revolved around the horizontal axis in a vertical plane completely. It can be rotated in a vertical plane for some limited angle. These theodolites are now become obsolete. Next, based on an arrangement to measure the angle, first is vernier theodolite. So the theodolite in which vernier is fitted to measure the angles is called vernier theodolite. It can measure an angle up to 20 minutes. So you can see its image here, okay. Next is micrometer theodolite. The theodolite in which micrometer is fitted to measure the angles is called micrometer theodolite. So it can measure an angle up to 1 minute. It gives more accuracy. So you can see its image here. Next is electronic digital theodolite. In electronic digital theodolite, the reading of angle is obtained in digital form. When EDM, say electronic distance measuring instrument is attached to the electronic digital theodolite, it becomes total station. So you can see its image here. So next, moving forward to some most important definitions which we have to understand before using the theodolite. Okay, so you can write down all definition. Okay, so first of all, centering. The setting of a theodolite exactly over a station marked by means of plumb bob is known as centering. Next is transiting. The method of turning the telescope about its horizontal axis in a vertical plane through 180 degree is termed as transiting. In other words, transitings result in a change in phase. So next is phase left. Phase left means that the vertical circle of the theodolite is on the left of the observer at the time of taking readings. Next is phase right. This refers to the situation when the vertical circle of the instrument is on the right of the observer when the reading is taken. Next is changing phase. The operation of bringing the vertical circle from one side of the observer to the other is known as changing phase. Next is swinging the telescope. This indicates turning the telescope in a horizontal plane. It is called right swing when the telescope is turned clockwise and left swing when the telescope is turned anticlockwise. Next is line of collimation. So it is an imaginary line passing through optical center of the object glass and its continuation. Okay, so you can see it in the image. So line of collimation is here. Okay, and you can see diaphragm of telescope is here, and here is the whole arrangement of telescope. So line of collimation will be this one, red one. Okay. Next is axis of telescope. The axis is an imaginary line passing through the optical center of the object glass and the optical center of the eyepiece. Okay, so we can see telescope here. So from the center, okay, axis of telescope will pass from the center of object glass and optical center. Okay. Next is axis of bubble tube. So it is an imaginary line tangential to the longitudinal curve of the bubble tube at its middle point. So you can see it in the image. So here is the image of axis of theodolite. So all this axis is very important. So be sure you know each and every axis. Okay. So now we are going to discuss all the axes of this. So first one is vertical axis. It is the axis of rotation of the telescope in horizontal plane. Next is horizontal axis. It is the axis of rotation of telescope in vertical plane. Next is temporary adjustment. The setting of the theodolite over a station at the time of taking any observation is called temporary adjustment. Next is permanent adjustment. When the desired relationship between the fundamental lines of a theodolite is distributed, then some procedures are adopted to establish this relationship. This adjustment is known as permanent adjustment. Next, we are going to discuss about least count of the vernier. Least count means the smallest measurement the instrument can take. Okay. So this is the difference between the value of the smallest division of the main scale and that of the smallest division of the vernier scale. It is the smallest value that can be measured by a theodolite. Okay. So you can see here, okay, vernier scale is here and main scale is here. So vernier is marked in minutes and seconds, okay, 20 seconds, and part of a circle marked in degrees and minute. Okay. So let us see how it can be measured. So it is given by equation V is equal to D by N, where V is equal to value of smallest division of vernier scale and D is equal to value of smallest division of main scale and N is equal to number of small division or vernier scale. Okay. So least count of theodolites are generally 20 second and 15 second and so on. Okay. So be sure you know all the value from vernier scale and main scale here. Okay. So minutes and second will be given. Okay. Next is the diaphragm. So you can see its image. So the diaphragm is a brass ring consisting of a crosshairs or one containing a glass disc with fine lines engraved on it. So you can see line here, okay, here the black one, okay. So it is placed in position by turning 4 capstan headed screws and can be moved up, down or sideways when required. It is fixed in front of the eyepiece. The crosshairs may be made of fine platinum wire. Next, we are going to discuss about vernier transit theodolite. So here you can see its image and all the essential parts of it is listed. Okay, so now we are going to discuss essential part of it. It is most important here. Okay, so be sure you study it well. Okay, so let us start with the trivet. So it is a circular plate having a central threaded hole for fixing the theodolite on the tripod stand by a wing nut. It is also called the base plate. 3 foot screws are secured to this plate by means of a ball and socket arrangement, and the upper threaded part passes through the threaded hole in the tripod plate. So you can see its image here. Next is foot screws. These are meant for leveling the instrument. The lower part of the foot screws are secured in the trivet by means of a ball and socket arrangement, and the upper threaded part passes through the threaded hole in the tripod plate. So you can see its image here. Next is tripod. So it is a triangular plate carrying 3 foot screws at its ends. And next is leveling head. The trivet, foot screw and a tripod constituting a body which is known as the leveling head. So you can see its image here. Next is spindles. The theodolites consist of 2 spindles or axes, one inner and the other outer. The inner axis is solid and conical and the outer is hollow. The 2 spindles are coaxial. Okay, so you can see it here in the image. Okay. Next is lower plate. The lower plate is attached to the outer axis and is also known as the scale plate. It is beveled and the scale is graduated from 0 degree to 360 degrees. So you can see lower plate is here, okay, in the image. Next is upper plate. The upper plate contains the vernier scale A and B. It is attached to the inner axis. Its motion is controlled by the upper clamp screw and the upper tangent screw. When the clamp screw is tightened, the vernier scale are fixed with the inner axis, and for fine adjustment of the scale, the tangent screw is rotated. Next is plate bubble. 2 plate bubbles are mounted at right angles to each other on the upper surface of the vernier plate. One bubble is kept right parallel to the horizontal axis of the theodolite. Sometimes one plate bubble is provided on the vernier plate. The bubbles are meant for leveling this instrument at the time of measuring the horizontal angle. Next is standard or A-frame. 2 frames are provided on the upper plate to support the telescope, the vertical circle and the vernier scale. These frames are known as standard A frames. So you can see it in the image, okay, here. It gives shape like it gives the shape of letter A here, okay, letter A. So it is known as A frame, okay. Next is the telescope. The telescope is pivoted between the standard at right angles to the horizontal axis. It can be rotated about its horizontal axis in a vertical plane. The telescope is provided with a focusing screw clamping screw and tangent screw. Next is vertical circle. Okay, so you can see theodolite telescope is here and vertical circle is here, and here its image. Okay, so the vertical circle is rigidly fixed with the telescope and moves with it. It is divided into 4 quadrants. Each quadrant is graduated from 0 degree to 90 degree in opposite direction, with the 0 mark at the end of the horizontal diameter of the vertical circle. Next is index bar or T frame. Okay, so you can see its image here. It forms a shape like word T or letter T. So it is also known as T frame. So the index bar is provided on the standard in front of the vertical circle. It carries 2 vernier, say vernier C and vernier D. Okay, so you can see it in the image here. Okay, at the 2 ends of the horizontal arm. So the vertical leg of the index bar is provided with a clip screw at the lower end, by means of which the altitude bubble can be brought to the center. Okay, so you can see all the arrangement in the figure. Next is altitude bubble. A long sensitive tube is provided on the top of index bar. This bubble is brought to the center by the clip screw at the time of measuring the vertical angle. So you can see the bubble is here. Okay, here. Next is compass. Sometimes a circular box compass is mounted on the vernier scale between the standards. In modern theodolites, an adjustable through compass or tabular compass can be fitted with a screw to the standard. Normally, compass will not be there in all the theodolites. Okay. Next is tripod. The theodolite is mounted on a strong tripod when being used in the field. The legs of tripod are solid or framed. At the lower end of the legs, pointed steel shoes are provided so that they can be pushed into the ground. Okay, so you can see its shoes here in the yellow. Okay, so it is tripod's image. Okay. Next is plumb bob. A plumb bob is suspended from the hook fitted to the bottom of vertical axis of the centering the instrument exactly over the station point. Okay, so here is the plumb bob, and here you can see in this image the hook is fitted here. Okay, at the center, and plumb bob is here. Okay, at the center. Okay, so it is used for centering process mainly. Next is shifting head. The shifting head is a centering device placed below the lower plate but above the tri-batch so that the centering may be done after the instrument has been leveled. Next is finder collimator device. So the telescope is generally fitted with a pair of external sight or finder collimator for rough pointing of the telescope towards the object. So these are provided on the top of the telescope for ease of initial sighting. So you can see finder collimator device here. It is very small one. Okay, so here you can see what the finder collimator. Okay, so it is provided on the telescope for the sighting. So here are the important questions. So list down all the questions, and these questions are very important for your examination. Okay, so already we have discussed all these theories. Okay, so here I end my session. Thank you all of you.